Hello everybody, welcome to this week's episode of Roundtable Ruckus. Show format's going to be a little bit different this week. It is our episode 4, our series finale for this year. So with me as my co-host today, I have the Lander. And so Lander, can you introduce yourself to all the people watching at home?
Hey, I'm the Lander.
Thanks. So Lander's pretty new to this world. Kind of came about just in time for kickoff in September. But my name is Danny Blau. I am one of the product development engineers here at AndyMark, and I work on the FTC game as well. And so today we're going to be talking about delivering game pieces to the Lander, and maybe talking a little bit about sorting and kind of some of the other things that have popped up in the last week or so. So we've had, like I said, this is episode 4. So we've had episodes on drivetrain, we've had episodes on game piece collection, we've talked about considering for weight, and our first episode was about going up and down from the Lander here so that we can start the match latched and then get that big bonus towards the end. So if you have any questions about any of those topics, feel free to go watch the series. Now that we have a complete series, you can binge watch them all the way from the beginning. So one of the things that's sort of really important to kind of think about and consider when we're talking about game piece delivery is really trying to know and understand a lot of the different geometry problems that we're faced with and a lot of the different things that we have to contend with. So the big one for our friend the Lander here is knowing how high we have to go, and kind of trying to consider the full path of the game piece from where we collect it to how we have to score it, and also knowing like sort of how we have to go about scoring in the top, what our margin for error might be. So as you can see up on the table here, we've got some of our game piece collection items that we demoed last week. So we have sort of our single game element our twin single game element roller claw intake with our cute little flappy flaps, and then also our double wide claw so that we can grab game pieces. So now we got to start thinking about, we've got these mechanisms, we've got game pieces in our robot's control. Now we've got to go take those from the crater over to the Lander. So this task, like so many tasks in the first game, require a drivetrain, but we've already got that one covered. So we're going to assume that we can get our robot from where it collected the game pieces over now by our friend the Lander so that it's ready to score. So one of the key things that you have to keep in mind is how tall the Lander is, but we can't just go up to this height. We've got to go a fair bit higher so that we can clear this leading edge, and also sort of look at where the game pieces can land on the top dome here in order to fall into the correct cargo hole. And so that's one of the other things. So one of the benefits of our single game element roller claw is we can dispense one item at a time. So we can dispense our gold and then our silver, versus our double wide claw can only dispense everything all at once. So we know that the top of the Lander is about 26 inches or so off the ground. So making a robot that can go to 28, maybe 30 inches high, get the game pieces that high, will give us a lot of room to drop these in, and we can kind of play with that lineup. We're not right on the edge. So that's going to be one of our first major considerations. Now, how are we going to get up to, say, 30 inches high? One of the beautiful things is our robot can be upwards of 18 inches tall at the start of the match, or needs to fit inside of an 18-inch box. So one of the things that we can do is, okay, we have to go less than one robot height, and that gets us over to where we need to score. So now we're talking about sort of a single element lift system. So, and that could be like a telescoping lift system. A lot of times people call those elevators. That could be a single jointed arm system. And each of those has their packaging constraints, and each of those has some different things that we got to keep in mind. But we don't need a big multi-element arm. We don't need a multi-element, multi-stage elevator to get there, because we're only going less than one interval of the robot's height. So one of the things that may be really helpful is that there is a lot of prior art to doing a single stage elevator. There's a lot of these in relic recovery, so there's a lot of people with a lot of experience out there, and a lot of people who've already gone through and done the troubleshooting for a lot of these, you know, sort of mechanisms. So and we've seen some of those mechanisms come out already in some of the early build broadcasts and some of the things that teams are showing off and being proud of. So, you know, there's definitely a lot of experience, a lot of knowledge there. So if you have questions of those, feel free to ask in either the subreddit or maybe some of the forums, or ask some of the teams that are local to you. You know, see what kind of expertise you can glean from those groups. One of the things that we didn't see a lot of in relic recovery, and one thing we're going to try to touch on a little bit more here today, is doing a single jointed arm. Now, one of the toughest things about doing an arm is sort of building a system that's going to roll nicely, so that as it swings from, you know, stop to stop, you know, it transitions really nicely and doesn't have a lot of friction. But then the second biggest thing to keep in mind is the powertrain that we put behind it. So what kind of gear ratio, how many motors, you know, what kind of mechanical advantage, what kind of simple machines. This is a great opportunity to go look up the various types of simple machines. And start to try to figure out how you're going to apply that mechanical advantage to your system. So, and also one of the things that's a little bit trickier with an arm is how do you package it for the start of the match. Now, an elevator is kind of a little bit more straightforward. It all just collapses down into, you know, one kind of unit size of itself. But an arm's a little bit trickier. You've got to find a full path, you know, of rotation for that device. One of the nifty things about the starting size and where we're trying to go this year with that single jointed arm, if we start with, you know, if we put that pivot point, say high on the robot, we need to put it there so that we can get the height to go onto the top of Mr. Lander here. But we also need to go and bring our game piece collector down to the floor. So having a mechanism that can go from the floor up to 30 plus inches high kind of dictates that we need to put that pivot point sort of high in the robot and let the arm swing through both vertical for scoring and low down for game piece collection. But now where do we store that? Because as the arm comes down, it's going to have to be out in front of the robot a little bit. And maybe we want this arm to be so far out in front of the robot that we can score from, you know, we can collect from the other side of the crater. And so one of the interesting, one of the cool bits is, you know, now we're talking about, we have the vertical front plane of the robot. We know our pivot point's going to be up high. We have the horizontal kind of section of the drive base. Well, the hypotenuse of that triangle is more than 18 inches. So we can stow our arm sort of between, on sort of fold it over onto the back side of the robot, roll it all the way over, collect our game pieces, go up vertical, score them that way. So there's kind of a really nice packaging that sort of exists in where we can put these different components for the arm. So, so that's really neat. So we're gonna, we've got a quick mock-up of that, but we're gonna get to that a little bit later. One of the other big things to keep in mind is the powertrain. So how many motors, what kind of gear ratio you're running, do we need to run more than just a stock gearbox, and how are we gonna be able to go do that? Do we need a secondary gear reduction? Do we need a secondary like chain and sprocket reduction? How are we gonna kind of go about doing that? So one of the rules of thumb that we've sort of come to know here is that it's really good if you can have about 10 times the amount of stall torque as you think your arm is going to need at its worst case scenario. So the most torque that an arm is ever going to need is when it's horizontal, straight out from the pivot point. The center of gravity is the farthest away from the point of rotation, so that torque load's the highest. And so if you kind of weigh the arm, if you find its center of gravity, you can apply the sort of the required torque load to hold the arm straight out. And then you want to try to shoot for a 10-to-1 multiplier on that, and that'll give you a lot of kind of power to move that arm very smoothly. And then you don't want something kind of, you know, jerking and bouncing around. So having something that moves really smoothly, really effectively is the ideal case here. So that 10-to-1 advantage can be, you know, is what we found to kind of be the sweet zone. Now that can be achieved from a couple ways. One is, you know, just having that much torque behind the system, so either adding motors or adding mechanical advantage, or you can also get a little bit of that by ballasting the arm. So if you have an arm that, you know, has a counterbalance on one end, on the opposite end, now all that gearbox needs to do is sort of overcome the inertia of the system. You don't need quite so much you don't need as much torque to be able to move that system because it's naturally balanced. And so you can do that with a counterweight, but with the weight limit this year, that's a bit of a trick. But you can also do that with stuff like springs or surgical tubing, and take out that ballast that way. So those are some things to kind of keep in mind, and we'll sort of talk through some of our solutions as a little bit later on. But those are just some of the various things to consider. And one of the things that you definitely need to keep in mind with an arm is you want to try to keep the weight close to the pivot point, and that definitely is a big challenge when you have stuff like grippers or you have these various claw elements, and they're now out at the end because they've got to pick up and score. So you really got to try to wherever you can try to move that weight closer to the pivot point. That just reduces the amount of loading that you need to have on the system. Very cool. So I think we're gonna do a sweet smash cut here. We're gonna clear the table. We're gonna kind of show off our solution a little bit. All right, welcome back from that sweet fade transition. So here is sort of the a tile runner chassis. We've got some superstructure on here made out of our S3 stuff, S3 tubing and various gussets and brackets and things. But really what we want to try to focus on today is sort of some of the arm geometry and the powertrain that we've got going on here. So like I talked about, we want to try to make sure that the arm rolls really smoothly. So what we've done is we've got a couple of Pico box plates here, 3 bearings in total, and a steel shaft. And what this system allows us to do is really support that shaft really, really well and support both sides of the shaft with respect to our where the load is going to be coming in from the main beam of our arm here. And one of the things that we want to do there is wherever we can, we want to try to avoid what's called cantilevered loads, where all of our support is on one side of the shaft and all of our loading is on the other side. That puts just a phenomenal amount of extra twisting loads and all sorts of extra forces into our system, whereas if we can just support it on both sides of the load, then we cancel out a lot of those effects. So that's definitely something to keep in mind. Here it was pretty simple. We had the space. We used some of the slotted features in the S3 tubing so that we could position these just right exactly where we wanted them. But now we have really good solid support on either side of our load, but we still have sort of free range of motion to go all the way back and forth and from one side of the robot to the other. So on the other side, we have our powertrain. Now, by using another of our PicoBox sort of single series gearbox mount plates, we have the ability to guarantee that the axis of rotation over on this side and over on our support side are coaxial. They line up with one another. And that's really important. Any sort of misalignment will help with adding a lot of drag and adding a lot of resistance to the system. So we really want to try to make sure that we're using a lot of parts really effectively to help us out and make sure those things are aligned. That just prevents a lot of fine tuning and adjustment later on down the road. So as you see here, we're powering with one Neverest motor. One of the benefits to the Neverest is it has a really phenomenal stall life. So you can put sort of the full 12 volts to these motors, lock the output shaft, and just run them without, and just put a ton of power to them without them spinning. And that's the worst case scenario for heating up a motor and eventually making it explode. Not explode, burn up. And so the Neverest motor is really, really good in those conditions. So it can go a little bit more than, just right around 3 minutes at stall before it burns up. The Neverest motor is going to do well in this sort of application where we are going to be stalling or loading this arm and throughout the course of the match and all over the place. But then to help it out, we put one of the Neverest Sport gearboxes from AndyMark, and this is a 4-stage unit. It is a 256 to 1 gear reduction. So for every time the motor shaft spins, 256 times, the output shaft will spin once. So we're trading a ton of speed for a phenomenal amount of torque. One of the other big benefits of using the Neverest Sport for an arm or an application sort of like this is the nub-shaped output shaft means that we can tie directly into 2 of those bolt holes and now use those elements to carry the torque as opposed to relying on any sort of shafting, BMD shaft or 3/8 hex or something like that. So now we have a phenomenally strong way to carry those torque loads. So This here is one of our 448 millimeter long S3 beams, and this is sort of forming the backbone of the arm itself. And so this beam is just shy of 18 inches, so we know that when we are at full extension, we have more than enough height to get to where we need to go. We can stow the arm down here inside the robot. We're inside the plane on this side, so we know everything is well within the shape of the robot. And then when we roll the arm over onto the back side, we can reach down towards the floor and help collect some of the pieces that way. So we have a really effective way of sort of being able to start inside that 18-inch box and then also kind of go through and play the whole game with a single point of articulation. So that's kind of a way to go through and package an arm in a system like this. And so I wanted to kind of help springboard everybody, kind of get some ideas flowing. And to everybody who had some ideas flowing out there, you know, one of the things that's really, really important is to always be keeping up and always be keeping track of what's going on in the game Q&A, what's going on in the official forums and any of the official replies that are coming in from First Headquarters. They are responding to questions, they're answering questions, kind of keeping, you know, letting the game sort of move and evolve and grow, you know, as more people have more ideas. And so there's a lot of stuff kind of happening on that front. So always be mindful. You don't want to get to your first tournament and have missed something in the Q&A, have missed any of the updates or changes that might have come along, and not be able to have your robot sort of compete to its fullest. So always keep an eye on those things. The FTC subreddit sort of is a good barometer for, you know, if anything sort of major, any shakeups, you know, kind of happen. But that's not an official correspondence, you know, with, you know, First. That's not official game stuff. So always be going back to the First Q&A. That's where the official answers do live. And so, you know, that kind of segues us into some of the things that have been being posted up in various social media outlets. So I want to give a big shout out to Redneck Robotics. They posted a really cool sort of teaser video on a mechanism from their robot that, you know, now is, they're going to have to tweak and tune, you know, but they were able to go through and score a whole bunch of points, you know, really, really fast up here into the lander. And yeah, the exact implementation of what they were going for in that first concept may not be legal now, but never throw a good idea away. You know, always, you know, you may need to scavenge some parts off of those things, you may need to rebuild some stuff, but always sort of have a lot of those concepts, have a lot of those game ideas in the back of your head, because you never know when that idea, you know, maybe with a little tweak or a little tune, may be the right thing for the next game challenge or a different facet of the game challenge. So, you know, it may be tempting to sort of, you know, crumple up your paper and throw it away and, you know, see, you know, and try to like, and just say, oh, we're just going to start over. But you know, always keep a catalog of those good ideas in mind when you're kind of going through that process. You know, it may be a lot easier to tune or tweak, you know, a mechanism that you guys already have as opposed to scrapping it and starting over. So this week's episode is a little bit shorter. We've got you know, some various things going on here at AndyMark that we are trying to, you know, make sure we stay on top of. So we are always excited to chat with you guys. If you have any questions, you can email support@andymark.com or customer service @andymark.com, or the email address that's being displayed down here on the bottom of your screen. So if you can, like this video, share it, subscribe it. We are here on Twitch all sorts of different times, so you would never want to miss a thing. So we wish everybody the best of luck as we start getting closer to tournament time, and we can't wait to see what kind of robots you guys put out on the field to go play Rover Ruckus. So thanks a lot for watching, good luck, and have fun this year.